Okay, here we go again. We are in Trig Guided Notes, section 1-2. Hopefully a lot more review. Angle relationships and similar triangles. So this first page we're going to start out with some key definitions of terms as we start talking about special angle pairs. First, vertical angles. Vertical angles are pairs of angles that are opposite each other and they're formed by any two intersecting lines. Formed by two intersecting lines. So it doesn't matter what angle my lines run into each other at. When I have two lines that intersect, they form four angles, 1, 2, 3, 4. Vertical angles come in pairs and they have equal measures. Now visually it ought to be pretty pretty evident that angles 1 and 3 are vertical angles with the same measure. And then I've got angles 2 and 4 that are opposite each other. So they are vertically across from each other, and they visually, you can tell they have the same measure. Okay, parallel lines are lines in the same plane that never intersect. Two lines in the same plane on the same flat surface that never intersect. So we would talk about parallel lines in college algebra as having the same slope. They are oriented in the same direction. If those lines are crossed by a third line, we call that third line a transversal. A transversal is any line that we talk about intersecting a pair of parallel lines. I would say down here that these two lines are cut by a transversal. If this is line M, this is line N, let's say this is line Q. M is parallel to N, and Q is my transversal. You can see that 8 angles are formed. And these 8 angles create several special angle pairs. And that's what we're going to focus on that next page. Now, we've already talked about vertical angles. Hopefully you can pick out 4 pairs of vertical angles here. So take a second and see if you can find the vertical angle pairs. Remember, vertical angles will have the same measure. Angle 1 and angle 4 are vertical angle pairs. Is a pair. Angle 2 and 3 are a vertical angle pair. 6 and 7, 5 and 8. Those are my 4 vertical angle pairs. So let's look at the next page. And the next page has this same set of lines drawn. Hopefully you're starting to realize you don't have to print the notes, but it definitely will save you a lot of work, and it will give you something very structured to look back at. Remember that our vertical angles have equal measure. We just picked out those vertical angle pairs. The next type of pairs we're going to talk about are alternate interior angles, alternate interior angles. Interior means between the parallel lines. So they are interior to the parallel lines, so in between. And the alternate part is on alternate or opposite sides of the transversal. So the name alternate interior angles give you the location. They are interior to the parallel lines and alternating sides of the transversal. Alternate interior angles have equal measure. There's only one pair here. Angle 4 and angle 5 is your only pair of alternate interior angles. Is that true? That is not true. Angle 4 and angle 5 is a pair of alternate interior angles. There's one other pair of alternate interior angles. If you look here, 4 and 5, also 3 and 6. Angle 3 and angle 6 are another pair of alternate interior angles. All right, let's look at the next one, alternate exterior angles. Alternate is still on alternating sides of the transversal, but now we are exterior on the outside of the parallel lines. So we've got right here, we've got angle 1, angle 8. They are alternate exterior angles. Their measures are also equal. And if you look at the exterior sides of the parallel lines, you see that there's another pair of alternate exterior angles. So we've got angles 1 and 8, as well as angles 2 and 7 as our pairs of alternate exterior angles. The next special angle pair that we're going to look at are those interior angles, so interior to the parallel lines on the same side of the transversal instead of alternate sides of the transversal. So we're talking about, for example, angles 4 and 6. Now I can look at angles 4 and 6 and I can see that they are not the same size. So they are not equal measures. Instead, their sum is going to be 180 degrees. They would be straight angles. Because let's kind of think through this. We know that, for example, angle 4 is the same measure as angle 1, right? Angle 1 is the same measure of angle 8, so angle 4 and 5 are the same measure. We know that 6 is the same measure as 7, and we know that 7 and 2 are the same measure. So if 2 and 4 form this straight line, and 2 is the same measure as 6, then 4 and 6 would also form a straight line, or be a straight angle, or sum to 180 degrees, however you want to word that. Alright, and then finally, we just kind of use this reasoning. Corresponding angles are in the same relative position to all of the lines. They're in the same relative position if they are corresponding. For example, angle 2 is above the parallel to the right of the transversal. Angle 6 is above the parallel to the right of the transversal. What do you think about their measures? Well, their measures are equal. So angles 2 and 6 are corresponding. And it gives you the other pairs, obviously, but angles 2 corresponds to 6. 4 is in the same position as 8. Angle 4 and angle 8 are in corresponding positions. Angle 1 is to the left of the transversal and above the parallel, so is angle 5. And finally, angle 3 is below the parallel to the left of the transversal, so is angle 7. So angle 3 and angle 7. Those are my 4 pairs of corresponding angles. Alright, Hopefully this is mostly review for you, or it will be simple enough to pick up as we go on and we use it moving forward. Finding angle measures. Well, you've got to know how they relate to each other positionally to help figure out what the missing measures would be. We want to find the measures of these 4 angles, 1, 2, 3, 4, in the figure, given that M and N are parallel, and we've got a transversal cutting through here. And we're asked to find the measures of all 4 angles. Now, I was given some information about angles 2 and angle 3, and I see that 2 and 3 are inside the parallel lines on the same side of the transversal. So they are interior angles on the same side of the transversal. And when I come over here and look at my sheet, interior angles on the same side of the transversal are supplementary. If angles add up to 180 degrees, they are supplementary. So I can use that information and say, all right, well, angles 2 and 3 are supplementary. So angle 2 plus angle 3 is 180 degrees. And I can write angle 2 as 9x plus 9. I can write angle 3 as 7x minus 5. And then it's just solving an equation. Combine my like terms. I get 16x. 9 minus 5 is 4. And I discover that x is 11 degrees. Now, x is not an angle in and of itself. It just lets me figure out what the angle measures are. For example, angle 2 is 9x plus 9 degrees. So 99 plus 9 is 108 degrees. And if angle 2 and angle 3 are supplementary to each other, if they add up to 180, and angle 2 is 108, then I know that angle 3 would have to be 72 degrees because they're supplementary. I also see that angles 1 and 2 are vertical angles. They're a special angle pair, and they have the same measure. So angle 1 will be 108 degrees. What about angle 4? Well, 3 and 4 together form a straight angle, and it is in the corresponding position of angle 2. So angle 4 is going to be 108 degrees. Okay. Triangle, the angle sum of a triangle. The sum of the measures of the angles of any triangle, it doesn't matter how big, how small, what shape, any triangle, the 3 interior angles in a triangle are going to sum to 180 degrees. They're going to add up to be 180 degrees. Now that's important to us because that means if we know the measure of any 2 angles in a triangle, we also know the measure of the 3rd angle. For example, if I know that the 2 angles in a triangle are 33 degrees and 26 degrees, and I need that missing 3rd angle, I can just figure out the sum of what I have and subtract that from the total 180 degrees. So I can figure out that that 3rd angle would have to be an obtuse angle, 121 degrees. Because the sum of 3 angles, any triangle, is 180, then I can always find that missing 3rd angle if I know the measure of 2 angles in the triangle. Alright, let's look at the next page, still focusing on triangles and types of triangles now. We can classify triangles either by angles or by sides. Now, if we classify them by angles, we have 3 options. If all 3 of my angles are less than 90 degrees, we call that an acute triangle because all 3 angles are acute angles. If I have 1 right angle, then it's a right triangle. Makes sense so far, right? And 1 obtuse angle is an obtuse triangle. Now, let's think about this. Can I ever have more than 1 obtuse angle in a triangle? Well, by definition, an obtuse angle is more than 90 degrees. So let's say that I have one angle that's 92 degrees. Can I have another angle that's bigger than 90? Well, let's say the other angle would be 91. That would add up to 183 degrees. That's too many degrees to be a triangle. There's no triangle, because the sum of the three angles in a triangle is only 180. So if I have a right angle, I can't have two right angles. The other two have to be acute. If I have an obtuse angle, that's the only obtuse angle. The other two have to be acute. I can have all three be acute angles. The other way to classify triangles is by the lengths of their sides. If all three sides are equal, it is an equilateral triangle. If two sides are equal, it's isosceles. And if no sides are equal, all three sides are different lengths, it's scalene. And you can see the marks. If the sides have the same number of tick marks, they're all the same length. For here, these two sides each have one tick mark, they're the same length. Here, my scalene triangle, each side has a different number of tick marks, designating that each side has a different measure. Similar versus congruent. Similar triangles are exactly the same shape, but different sizes. So it's like me and mini-me, right? An enlargement, photo and its enlargement. Exactly the same shape, but different sizes. Congruent, however, means exactly the same size and shape. Similar triangles have the same shape, but different sizes. Congruent triangles are the same size and the same shape. I know that I have similar triangles if the angles have the same measure, corresponding angles have the same measure, and the corresponding sides are proportional. That means the ratio of the sides must be equal. So if this side is 1 and this side is 2, then that ratio of 1 to 2 is going to hold for all three pairs of sides. Now, the sides are proportional, but the angles are equal. So when I look at this larger triangle DEF, if I know that these two triangles are similar, then I know that angle G has to be 53 degrees and angle F has to be 29 degrees. This triangle is smaller than that triangle. The angles are closer together, but the measure of the angles are the same. All right, now let's look at this one. We're told, anything you're given, you can count on. We're told that these are two similar triangles, so we need to find the lengths of the unknown sides. Now, we weren't given angle measures, so we are focusing on side measures. I can see, though, that they are oriented the same way. Angle M is congruent to angle Q because of the way it's marked. Angle P is congruent to angle R, and angle N is congruent to angle S. So their sides are going to pair up accordingly, which means that side PM corresponds to side RQ. It is between the angles of the same measure. That allows me to find these missing side measures. Let's go ahead and let's label this X and this Y just so it'll be easier to talk about. Side MN is going to correspond to side QS, and side PN is going to correspond to side RS. So the side pair that I know is this one, 8 to 12. And you can set these up in different orders. I like to set it up corresponding sides, one side to the other. So if I do 8 to 12, that's the pair that I know. I can use that to find a pair that I don't know. So 8 to 12 is going to correspond to 12 to Y, because that's my other pair of corresponding sides here. And I also have, because this is my known pair, I'm going to start with it, 8 to 12 should be equal to this relationship 10 to x. Now to solve a proportion, you solve using cross products. So I find those cross products. 8 times y is equal to 12 times 12, which is 144. And then I solve for that side length y. And I have 144 divided by 8 is 18. So y is 18. And over here, 8x is equal to 120. And I solve for x, and I get that x would be 15. That's how I use proportions to find those unknown side lengths. Alright, let's look at a couple of application problems before we're done. Joey wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow at the same time that Joey, who's 63 inches tall, casts a 42-inch shadow. And we need to find the height of a tree. Now, sketches in Trig are vital. A nice, simple, accurate sketch will make things so much easier. So I've got a tree. Doesn't have to be a pretty tree, but I've got a tree. And that tree is casting a shadow. So the tree is, we don't know how tall the tree is. The tree is X feet tall. The shadow is 38 feet long. The shadow along the ground is 38 feet. And then we've got Joey standing over here, and we know how tall he is. And at the exact same time, when the sun is at the same spot in the sky, he casts a shadow that is 42 inches long. And we know that Joey is 63 inches tall. Now, the first thing that I notice is I've got feet going on over here, and I've got inches going on over here. Now, if I set up my ratio correctly, I don't need to worry about making conversions because my ratios, the two different ratios don't have to have the same units when I set up my proportion. I can say feet to feet is equal to inches to inches. And just like with dimensional analysis, we would divide out those units, we consider that those units would divide out here as well. So we've got X feet tall, is how tall the tree is, casts a 38-foot shadow at the same time that my 63-inch tall Joey cast a 42-inch long shadow. So these two comparisons are proportionate. I have similar right triangles drawn. They're not the same size, but they are the same shape because the measurements were taken at the same time of day. So I can ignore my units. I can do my cross products. I end up with 42x is equal to 63 times 38. Plug that into your calculator. You get 2,394. And I divide that out. And I get a value of 57. And I know that this is feet because that is the height in this ratio. The units are being measured in feet for this ratio. So my tree is 57 feet tall. Does that make sense? Yes. Joey was taller than his shadow is long here, so the tree will be taller than the shadow is long here. So always do a quick sketch, make a nice accurate sketch, and then take a second to stop and consider if your answer makes sense. Alright, last one for this section. Workers at the fire station need to know the height of the station's flagpole. They find that at the same instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 99 feet long. I don't know why one group was measuring in meters and one group was measuring in feet, but that's fine. We can work with it. They know the station is 10 meters high. So as long as we have the units the same for each ratio, we're in good shape. So we've got a 10-meter tall building casting an 18-meter long shadow. So the sun is definitely in a different spot, right? Because the shadow is longer this time. So a 10-meter tall building is casting an 18-meter long shadow. There's one right triangle. That's supposed to be a straight line, sorry guys. And then we got that flagpole out there. And that flagpole is 99 feet tall. And it's casting a shadow. Oh, nope, I did that, labeled that backwards, didn't I? We don't know the height of the flagpole. That's what we're looking for. That's okay. We can fix it. X feet tall flagpole that's casting a 99-foot long shadow. So there's my 99-foot long shadow. There's my other right triangle, and these are similar right triangles because we took the measurements at the same time of day. Since I can set up my proportion with the same units on one ratio and the same units on the other ratio, those units would cancel out, and I'm finding this missing value here, and I don't need to worry about my units not matching from one ratio to the other ratio in my proportion. Alright, solve a proportion using cross products. 10 times 99 is equal to 18x. And we figure out that our flagpole is 55 feet tall. Now, when you are doing application problems, make sure that you round if you're asked and that you always give units as appropriate.